Have you ever stopped to think about rivers flowing not on land, but deep within the oceans themselves? Well, that's exactly what we're diving into today. The massive, powerful, and pretty much invisible system of ocean currents that shapes our entire world. Let's trace these hidden rivers and find out just how huge their impact really is. And that's really the perfect way to think about it. These aren't just random sloshing of water. Nope. They're driven by things like wind, the Earth's rotation, and even differences in water temperature. They are organized flows, actual deep rivers with set paths, carrying incredible amounts of energy clear across the globe and influencing everything from our weather to entire ecosystems. So, here's our game plan for this explainer. First, we'll get the basics of these ocean rivers down. Then, we're going to take a tour of the big circular flows in the Atlantic, the Pacific, and the really unique reversing system of the Indian Ocean. And finally, we'll tie it all together to see why these currents are so incredibly important to our world. Okay, so to really get a handle on how these currents work, we can start with a simple but super important distinction. At their core, they're pretty much divided into two main types, and it all comes down to the temperature of the water they're carrying. You can almost think of it as the planet's circulatory system, right? Warm currents act like arteries, carrying all that tropical heat away from the equator up toward the poles, and the cold currents are like veins, bringing the cooler polar water back down. This fundamental push and pull is like a giant engine, constantly working to balance out the Earth's temperature. Our first stop is the Atlantic, and it's home to one of the most famous current systems on the planet. These currents form these huge circular patterns called gyres. And they don't flow in straight lines because the Earth is spinning. It's a phenomenon called the Coriolis effect, which bends them into these massive loops. It all kicks off with the warm north equatorial current. This current pushes water west, basically funneling it right into the Caribbean and the Gulf of Mexico. Then, as all that water gets squeezed out through the narrow Florida Strait, it picks up speed, becoming the Florida current. And finally, as it moves up the U.S. coast, it transforms into the legendary Gulf Stream. But as this massive river of warm water travels north, it's not alone out there. It's on a collision course with a very, very different kind of current flowing down from the Arctic. This is one of the most dramatic showdowns in the entire ocean. So what are the consequences? What happens when all of that immense warmth slams into that polar cold? Well, two huge things happen here. First, that extreme temperature difference creates this famously thick, persistent fog, a major hazard for ships for sure. But second, and way more important for the ecosystem, the collision churns up nutrients from the deep sea. This causes an explosion of plankton, which makes the Grand Banks of Newfoundland one of the absolute richest fishing grounds on the entire planet. After this big meeting, the current heads east across the Atlantic. To complete that big circular gyre, it flows south along the coasts of Europe and Africa as the cold Canaries current. And this cold current has a dramatic impact on land. The cooler, drier air it brings is a major reason why the vast Sahara Desert exists right next to the ocean. And get this, the Atlantic has a mirror image in the south. The South Atlantic Gyre works on the exact same principle, just flipped. You've got the warm Brazil current flowing south, and the cold Benguela current flowing north, completing its own massive circle. All right, let's hop over to the vast expanse of the Pacific Ocean. Now, we're going to see the same principles we just talked about, but playing out on an even grander scale. You'll see a familiar pattern here. The North Pacific has its own version of the Gulf Stream. It's called the Kuroshio Current, or Black Stream, because of its deep blue color. This powerful, warm current flows north along Japan's coast until, you guessed it, it collides with a cold current, the nutrient-rich Oyashio Current. And just like in the Atlantic, this convergence creates one of the world's most vital fishing zones. So as this combined current crosses the Pacific, it eventually runs into the North American continent and splits in two. Part of it flows north as the warm Alaska Current, and the other part flows south as the cold California Current. And just like the Canaries Current, this cold water off the coast contributes to lower rainfall and helps create the arid climates you see in the western U.S. The power of these cold currents to shape the land gets even more dramatic in the South Pacific. Here, the cold Peru Current, which is also known as the Humboldt Current, flows north along the coast of South America. Its cooling effect is so profound that it's the primary reason for the existence of the Atacama Desert, literally one of the driest places on the face of the Earth. Now, for our third ocean basin, the Indian Ocean. Its northern half behaves unlike any other ocean on the planet. and it's all thanks to the powerful influence of the land masses around it. The defining feature here is a complete seasonal reversal, and it's all driven by the monsoon winds. It's fascinating. In the summer, powerful southwest monsoons blow from the sea to the land, pushing the ocean currents in a clockwise direction. But in the winter, the winds completely change direction, blowing from the land out to the sea, and the ocean currents totally flip, flowing counterclockwise. This massive, predictable reversal has shaped trade and travel in this region for centuries. South of the equator, however, things are a lot more stable. The southern Indian Ocean has a more conventional gyre, just like the other oceans. It's driven by the incredibly powerful and warm Agulhas Current flowing down Africa's east coast, and it's balanced by the cold West Australian Current flowing north. So we've now toured the entire globe tracing these immense ocean rivers. But let's bring it all home and really underscore exactly why this matters so much to every single one of us. I mean, it's one thing to know their names and their paths, but what's the big deal? How does a current thousands of miles away really affect our climate, our food supply, and even our life on land? This slide really pulls it all together. As you can see, cold currents like the Canaries and Peru currents are directly linked to the formation of huge coastal deserts. The meeting of currents like the Labrador and the Gulf Stream creates our most vital fishing grounds, and powerful warm currents transport so much heat that they make places like Western Europe far warmer than they'd otherwise be, essentially regulating the entire global climate. When you step back, it's clear there are so much more than just water in motion. They really are the planet's great engine. They're transporting heat, they're shaping weather, and they're sustaining life in the sea. They are a fundamental force that makes our Earth habitable. And you can never forget the sheer scale of what we're talking about. The system operates across more than 70% of our planet's surface. It's a single, interconnected network that physically links every ocean and every continent on Earth. And that leaves us with a really critical question for the future. This entire system is driven by temperature and wind. As our planet continues to warm, the stability of these absolutely vital ocean rivers is not guaranteed. How might they shift? And what happens to our weather, our food supplies, and our climate if they do?